Thank you, Leon. Thank you for the very nice presentation, Jakob. And now we are going to, before starting our panel, now we are going to learn more about our panelists. And the first one is Carrie Ann Wagner from Aarhus University. Carrie, the stage is yours.
Thank you. Thank you very much. Happy Friday night, everyone. Thanks, Jacob, for the great presentation. So I am an assistant professor at Aarhus University. I started at about 3 years ago as a postdoc, actually, working for Jacob, and now I work with Jacob, much to his chagrin. And so I am primarily trained as an experimental physicist in various aspects of quantum technologies. I've worked in sensing, I've worked in simulation, I've dabbled a little bit in quantum information and whatnot. Basically, if it's quantum, I either like it or have done something with it. I also have dabbled a little bit in some theory, some computation, and I'm very interested in quantum education, sort of spanning all from the high school through bachelor's, master's, out to the general public and industry workforce training and whatnot. Currently, most of my focus is on sort of the post-secondary education level. But that's everything is pretty cool and interesting. I'm originally from the US. I was born and raised in Texas, educated in Colorado, out in the Rocky Mountains, and then came out here to Denmark. And it's a nice place to be. So that's me.
Okay, thank you, Carrie, for your presentation, and thank you for your introduction for the panel. Next up, we have Tatiana Wilk from Munich Center of Quantum Science and Technology, who will also be joining us for the panel. Tatiana, floor is yours.
Yes, thank you very much. I actually prepared a small presentation to tell you a little bit about the work we do in Munich. So I myself, I'm also a physicist. So I did my PhD on single atom, single photon entanglement. And I also did some atom-atom entanglement and light matter interaction, cavity QED. So now, since 2019, I'm actually the general manager of MCQST, so the Munich Center for Quantum Science and Technology, which is a cluster of excellence funded by the German Research Foundation. It is a big project. It runs for 7 years, so since the beginning of 2019 until the end of 2025. And we have a total funding volume of about 43 million. It actually comprises different players. So we have here the LMU and TUM, the big 2 universities in Munich, but also the Max Planck Institute of Quantum Optics, the Walter Meissner Institute, and the Deutsches Museum. Our basic research topics, they include basically all topics of quantum science and technology. So quantum information theory, quantum simulation, quantum computing, quantum communication, quantum metrology and sensing, quantum matter, and also what we call explorative directions, where we would like to apply the methods we use in quantum to other fields, so like high energy physics also. So in MCQST, there are about 60 groups, so PIs, so principal investigators with their groups, which is in total about 380 researchers. So, and these come from physics, from mathematics, from chemistry, computer science, but also electrical engineering, for example. We have a very strong support program in MCQST, which basically runs or covers all levels of career levels. So, and now I would like to highlight a few to explain our educational initiatives. So we actually start already with working with students. So we have the Photon Lab, which is a laboratory for pupils, for high school students, and it already runs for like 10 years. So of course, at the beginning, there were more optics experiments, and now they get more and more into the quantum world. So here you see Silke Stehler-Schöpf, who is the head of the Photon Lab, and here you see her also with students and so on. So there are about 2,000 pupils per year that visit the Photon Lab with their class. But of course, this was pre-pandemic times. Now, actually, we have invested in online presence. So we have produced videos and descriptions of experiments. We also have virtual lab tours, which can all be seen actually on the web page of the Photon Lab. Zeki also offers teachers trainings, and she is present at science fairs, like we have one in the beginning of October in Munich. And she also offers students internships and helps students to prepare for students competitions in Germany or international as well. Okay. So we also have a bachelor's program where we invite students from all over the world to come to Munich. Well, actually, this time it was also only online, but we had a very international group of students which joined us for this week-long program. And we hope to actually invite them next year to come to Munich in real for about 4 weeks. Since 2020, so last year, we have also a master's program of quantum science and technology, which is a joint program of the 2 big universities in Munich, and which has now at the moment 35 students enrolled in this class. And we expect to have 65 students enrolled in fall. So the 2 driving forces here were Jan van Delft and Alexander Holeitner. Sorry. Well, we also have cooperations with the Deutsches Museum, which is a big science and technology museum in Germany. I think it's almost the largest of the world. And together with them, we are actually planning and preparing a permanent exhibition on light matter interaction, which will start in 2024. Until then, we also run a program for quantum technologies for beginners. And for example, we have created these cubes. These represent entangled qubits, for example, and they behave entangled. So they were even used when our Chancellor, Mrs. Merkel, visited the MPQ here. And you see here Professor Gerhard Rempe, who shows her and also the Prime Minister of Bavaria how entanglement works over large distances with these cubes. So we hope that these cubes will also be present in the museum soon. We have also organized a lot of public events like talks, but we are also present on YouTube with introductory videos on quantum cryptography. We have 360 degrees lab tours. We have a quantum Stammtisch where experts discuss topics about quantum science, and we also organize science slams. So subscribe to our YouTube channel and get entangled with us. Thank you for your attention.
Thank you so much, Tatiana, for this very nice presentation. Now I will continue with Maria Luisa Chiofalo from University of Pisa and QPlay Learn. Thank you very much, Marilu, for participating to this event.
Yeah, thank you to Elif and Leon for organizing this, and I think I can thank you also on behalf of Zeki Seskir, who is here with us and with whom we are co-coordinating this pilot project. We will talk about, I guess, during the panel discussion. So I just a quick presentation of myself as Carrie did. I'm a professor in condensed matter physics at the University of Pisa, the physics department, where I coordinate the teachers training initiatives. Besides, I mean, my research and education activity, my background and also my research is in quantum liquids and quantum technologies, mainly applied on one side on metrology and fundamental physics. Today, we had the second day of the workshop, the community workshop of the Network Edge, atomic experiments for dark matter and gravitation exploration in space, to set up a roadmap for the next possible missions with the European, the different European space agencies. On the one side, and on the other side, of course, my research is mainly in the application of theoretical knowledge on quantum fluids to quantum technologies, with mainly on the one side the use of superfluids for analog gravity, but also this proposal that we have been cooking up with a number of different scientists from different fields, that is called IQ Minds, that is mind-machine integrated quantum technologies, where computer scientists, neuroscientists, quantum physicists and game developers are involved, and I mean, a way to build up a kind of an interface to put together the best of human mind, that is about creativity and intuition, with the best of computer machines, either classical or quantum, that is algorithmics and logic. More recently, I became interested in mind and matter. We recently had this workshop in Helsinki, where I'm connecting from, even though I'm from Pisa. And of course, I've always been very, very active in outreaching and more recently in physics education research. And in particular, I'm here contributing to this panel with several hats, besides the University of Pisa hat, as Elif was mentioning, as QPlay Learn. That is a platform that has been created by Professor Sabina Maniscalco, University of Helsinki, and whose general director is Caterina Foti. And I contribute as a director of the Discover section. QPlay Learn is a platform, I think one of the several platforms that nowadays are aimed at educating general public and high schools and also companies about the beauties of quantum physics, but we will have time to talk about it, I think, about the general subject in the during the panel discussion. And okay, so this is me. Then I have several many other interests that are about music, but I don't think they are very relevant here. I really look forward to start the discussion, the panel discussion about our main topics today. And I think it is a great opportunity for the European Research Night, for the reasons that Jacob has introduced. I think this is really a hot topic, and I think we're doing a good job here.
Thank you very much, Maria Luisa. This was a very interesting introduction from your side. Next up is someone who you already mentioned. That would be Zeki Seskir. I hope I pronounced your name right. Coming to us also from Middle East Technical University, like Elif is. So Zeki, floor is yours.
Yeah, thank you, Leon. And yeah, you pronounced it correctly. Hi, everyone, and thanks for the invitation. I'm Zeki. I'm a last year PhD student at Middle East Technical University Physics Department, and my research is on quantum information science, mainly on entanglement purification algorithms for quantum networks. And I am also one of the coordinators of Quantum Technologies Education for Everyone pilot program. But also, as Marlo said, I have other hats as well. I'm one of the board members of QBOD, which is an international organization that is focused on, let's say, well, mainly on quantum education and allowing less developed regions to be engaged with quantum technologies. Right now, we have members, or let's say we have branches at 20 countries. We call them Q Cousins, which are independent. They're kind of local independent organizations, and QBOT itself is an NGO founded in Estonia. And I'm also one of the founding members and coordinators of Q Turkey, which is the local branch of QBOT in Turkey. We have been active since May 2019, and this was also due to the activities of Quantum Flagship, because we have been following the flagship developments very closely. And we also saw, as Jacob explained, that there will be an important aspect of, outreach and education and preparing the younger generation for, and including myself and probably Leon as well, for the following job market. So we tried to spread the message of quantum technologies to wherever we can. And that's it. So thanks.
Thank you very much, Zeki. So I think we can start with our panel, and maybe I can read the first question just to set the floor, maybe. So here is the question. How do you think quantum technologies help the EU to stay, as Quantum Flagship Manifesto says, at the forefront of technology? So how do you think the quantum technologies is going to affect Europe's position in the forefront technology?
I propose that we go in the same order as you managed to present yourself. So let's start with Carrie.
All right. So I thought about this question a little bit in terms of what I wanted to say here tonight. And I think there's two aspects that are important to touch on. At least there are two aspects that I will touch on, and then hopefully my fellow panelists will find other intelligent aspects. And one is kind of I'll mention the elephant in the room, so to speak, which is just simply that quantum technologies are here. They're not going anywhere. Certainly, we're in a very interesting regime in sort of the so-called noisy intermediate scale quantum regime, where we have these devices, and we're still trying to build the bridges between the academic laboratories and industry. And it's really fun to see how that's grown, even in the short time that I've been in the quantum sphere in the last decade or so. In that, the more we invest, and I count myself in as we, since I live in the EU, the more we invest into quantum technologies, the more we'll get out of it, both in terms of staying competitive within the global sphere, and really leveraging the most out of the people that live here. Because I mean, one of the things that I've noticed here working as an educator and as a researcher is that the people are really the important bit. If you can motivate people and encourage them to care about something, then they will really do wonderful things. And so being able to stay competitive in the quantum sphere is extremely important. With regards to all of these different initiatives that we're all a part of. But then there's another side benefit, I feel, and that's actually the technology development that is tangential to the quantum, that actually forms the foundation of what we do in the quantum realm, but that will find a place outside of the quantum sphere. The analogy that I like to build upon is sort of the race to the moon that occurred back in the Cold War era. Yes, we put people on the moon and they walked on the moon, but the sheer amount of technology that was developed to go from Earth to moon, things that were as simple as Velcro. I mean, we use that today. It's ubiquitous. When the laser was first invented, they said, "Oh, this is cool. We can do these. We can make these funny photons," but nobody will ever use them for anything. And now they're ubiquitous. They're everywhere. And so I think that we're really sort of standing on the precipice of developing not just purely quantum related technologies like computers and simulators and clocks and these sorts of things, but also the supporting technology, the infrastructure, the sheer amount of engineering that goes in to taking these quantum systems and protecting them from their environment and ensuring that we can do things with as well as possible, and really move out of this noisy intermediate scale age into the quantum is doing lots of awesome things with lots of potential benefit or at least impact to society. And so those are really the two most important things that I wanted to touch on.
Thank you so much, Kerry, for setting the stage. Now we can continue with Tatiana. Go ahead, please, Tatiana.
Yes, so I think Kerry touched the two most important points here, which is the people. I mean, we really have to invest in people. That's also from other educational sciences. It is actually every dollar you invest, it comes in return. I mean, there will be much more return, because you can have the best equipped laboratories, but without the people who can actually manage and which are creative, you're actually lost. So this is actually the most important thing. And we also see in Munich, for example, that there is a lot going on regarding also enabling technologies. So we have a lot of companies working in these fields, and they are actually, hiring our students from the labs, so to say. So they are stealing them. So there is a lot of actually, the companies just need this support as well. So they need the people, and we actually see that very clearly in our environment.
Okay, thank you, Tatiana, for your input. Next is Maria Luisa.
Yeah, so I entirely agree with what Kerry and Tatiana have discussed. I would say, I would provide a couple of answers, one on the research and application side and one on the educational side, and we'll leave the educational as the last point, given the specific aim of this panel and of the pilot project. So considering the research and applications, I think that it is important, given the fact that we are at the European Research Night, also to provide a general idea about what we mean by quantum technologies, to have also understand how much impact they can have, because one can imagine, so the word that is most often used is the one of building up a quantum computer, for example. It is something that okay, there is a lot of research, there are many huge achievements in the last years, but this is something that is still not at the immediate reach. And even and of course, when this will happen at some point, it will happen in some form. Anyway, this will be really a huge breakthrough in our lives. But even waiting for this far away time, what is happening right now with the development of quantum technologies in this second revolutionary era is that we can already imagine about applications that maybe they are not entirely quantum, but they are a combination of quantum and classical ones, where one can imagine, so this is the final goal, to have applications about making personalized therapies by conceiving specific drugs or vaccines, given the fact that we lived the last 2 years in the COVID time, or also specific fertilizers that can, for example, that can maybe not solve, but certainly help making a bit easier the problem of food shortage in the world, in a way that is not polluting and is enough efficient, or energetic problems, climate change, and a lot of applications. And this is all what, in a way, quantum technologies is about. But also, for example, I was talking in the presentation about, speaking about these fundamental physics explorations. Quantum technologies are nowadays the main door through which fundamental physics, a lot of fundamental physics can be pursued and realized. For example, for very fundamental tests of general relativity, or also about the possibility of, I mean, simulating specific kind of problems, quantum problems that in principle cannot simulate it in other and understood in other manners. So there is really a huge and a variety of different applications of quantum technologies. And then I come to what is at the heart of the efforts of the quantum technology education coordination support action that Jacob has introduced, and so that is indeed education. So educating to quantum technologies and also to quantum physics is very important because first of all, it is I mean, we generally have a problem in educating everyone to physics and to scientific thinking. And the reason is that scientific thinking hinges on essentially two kinds of basic literacies that are not at reach of everyone. One is the experimental literacy, and the other one, because you must have an idea about how to an experiment is performed, and when the experiment is performed, then you have to be able to read out something from, I mean, from the observation, making a fact analysis and so on and so forth. And the second literacy is the math literacy, the formal development, that is what you use to, that we use to make quantitative predictions out of say, a possible solutions, possible understanding of a given phenomenon. Now, both experimental literacy and math literacy is something that is not really at the heart of the educational systems, even you know, low grade educational systems. And for quantum physics, where we don't have a direct experience of the quantum phenomena on the one side, and on the other side, the math that you need is very complex and is very hard. They are very advanced tools. So you don't, even if you had this kind of literacy, then of course you need to do something more and something better to make the quantum, the strange and weird world of quantum physics accessible to everyone. And so from this point of view, quantum technologies represent, and quantum physics represent, a wonderful opportunity for educating everyone, first of all, to scientific thinking, and then also to all the beauties of these, quantum technologies that are going to revolutionize our lives, and that we must understand as citizens, as a European and worldwide citizens, because at the time they revolutionize our lives, we need to be aware about what they are, because we need to have consciousness on what is the impact and which are the implications in the use of these technologies.
Thank you very much, Marilu, for this very nice discussion. And I think we will be able to enhance it in the second part of our panel as well, since it will focus on education. Now I will continue with Zeki. Zeki, what are your thoughts on this first question?
Okay, thank you. I completely agree with all three of the previous panelists. And regarding the question, I think one of the things that we should note is that the world is at the verge of something called a techno-economic paradigm shift. And this is something from the evolutionary economics literature, and it argues that there are these techno-economic paradigms that we live in, and almost like every 50 or 60 years, there are some constellation of different technologies that come together and change this techno-economic paradigm that let's say the entire opportunity landscape is built upon. And the previous one was, the information technologies after the development of transistors, and the previous one was the mass production technologies, and the previous one was like railroads and steel and electricity and all of those. And in that sense, quantum, I think we should start thinking about quantum technologies in its relationship with other major technological developments as well. And as far as I can see, this is happening with AI in US and Canada. Both of the countries are merging those in terms of federal funding. Like if you read the White House reports, it is quantum information science and AI funding. It is not quantum information science and AI differently. And I think the same thing is happening with Canada as well, with their latest report. And as Marilu said, this is also very related to biotechnology and medical technologies, because as you know, quantum technologies have a very strong sensing and metrology related aspects as well, which is very directly connected with medical technologies. And I mean, one of the examples we all probably have used is as a practical quantum technology of the first revolution was MR, right? You know, the fMRIs and all of that came from the Rabi oscillations that we learn in our quantum mechanics course, etc. And one of the other things that we should note is, I mean, we usually discuss this like, oh, US is doing that, China is doing this, Europe is doing that, but the development of quantum technology is a matter that is important for the entire humankind, because it is allowing us to, let's say, harness the quantum capabilities. And when I'm saying this, it sounds like, you know, this quantum thinking or healing or stuff like that, but no, it is, we are learning and we are developing our capability to manipulate quantum systems and to transform them into ways that are beneficial to us. I mean, these benefits can be utilized for medical purposes, or, you know, destructive purposes, or computational purposes, or sensing purposes, but we are gaining this new capability as the humankind, and the entire world should, you know, chip in to this kind of development. And Europe is one of the most important centers for this, because, well, quantum theory was born here, and as far as I can see, it never stopped being developed in Europe, and in that sense, it is an important part. And for economics part, Europe should get into this bandwagon, because there is this supply chain being developed all around the world, and it has something called path dependencies. So the entire supply chain structure is being developed right now, and it depends on, which part of the world has the clean rooms, which part of the world has nanofabrication capabilities, which part of the world has characterization and testing centers, etc. And in that sense, I think it is really good to see that the quantum flagship is focusing on those parts as well, and not just, basic science or development of knowledge. I mean, those are very important, but also we should be careful about technology aspect of this as well. And this is something we discuss in the pilot, like, is it quantum physics, is it quantum technologies, which should we focus on in terms of education? Of course, they are very connected, but they are not the same thing. And in that sense, yeah, that is my answer.
Thank you very much, Zeki. This was actually quite a productive segment. Although we all agree that that quantum technologies are one of the ways that Europe can stay at as a forefront of technology, it is nice to hear that we are not alone in this thinking, but that basically the whole community shares the same passion about it. Now we will move on to our second part, our second question. Basically, in the light of knowledge that we need quantum technologies and that quantum technologies need to be developed here and not elsewhere, I mean, elsewhere as well, but we have to stay at the forefront, we need people who are trained to develop them. So we need to form some kind of and structure some kind of education for people who will one day work in quantum technologies. So what is your vision of quantum technology education? What does it include? When does it start? We'll start in the same order again with Carrie.
All right. Well, I will then do the exact same thing that I did last time, and that is touch on a couple of things that I think are particularly worthwhile, and then let the whole rest of the panel share their awesome ideas, because I couldn't agree more with what was said by everybody. So there will be no hot debate panel. I think it's just going to be a bunch of quantum love tonight. So what I thought about this also a good bit, because as I said in my brief little introduction, most of the educational work that I've focused on has been at sort of the bachelor's, master's, PhD, and even into sort of the postdoc level, because those are the populations that I interact with most. But I was answering a survey yesterday regarding what quantum education looked like in schools. So this is sort of the pre-secondary, pre-bachelor's education. And I feel kind of bad for this, but my gut was almost saying, well, why does a high schooler need to learn quantum mechanics? And I felt like I almost felt dirty for saying this, because, I love quantum mechanics. I'll do it every day for the rest of my life if I have my way. But so why wouldn't a high schooler want to know quantum mechanics? And so I thought about this a little bit, and I was having this internal battle, and I came up with a couple of things. And they touch on a little bit of what the others have talked about, in particular something that Mari-Lu mentioned. And the first thing about teaching quantum mechanics, you mentioned, where should it start? Teaching quantum mechanics at sort of the high school level. Of course, outreach. I've done quantum outreach with kids that are as young as 6, 8 years old. As long as they're old enough to walk into the lab, I can show them all of my lasers and all of the cool things that they can do. And kids love it, especially when you call them expensive Legos, because that's effectively what they are. But you at the high school level, because that's where, in my opinion, that's where formal education, with regards to sort of pushing things forward, where that can really get going. I think there are good arguments for starting younger, but let's just start at the high school level for the sake of things. There are a couple things. One is that's when I was inspired. I was pretty lucky. The day I set foot on a university campus, I knew exactly what I wanted to study, and I went in and I studied it, and I've just never stopped. I knew I wanted to be a physicist. And the reason why I knew I wanted to be a physicist is that I had amazing teachers in high school that were able to show me that this was actually a thing that I could do with my life. I don't have academic parents. I have wonderful supportive parents, but they're not academics. They didn't really know what physics is. They still think they assume I just freeze atoms for a living, which is kind of true. But it's something like that. And so the inspiration part, I think, is non-zero. You can inspire people. You can say, look, this is quantum. This is, you think everything you think you know about the classical world, will be fundamentally changed. And here are some experiments that show why this is. Here are some demonstrations that show really incredible things. And even if you get one kid in a class of 30 to go, wow, then you've done your job. But then the other thing, and this touches on what Maria Luke talks about, is that quantum mechanics is complex. It takes a lot. It takes years of study. Even after studying basically nothing but quantum mechanics for about a decade, more than that, I still don't really know anything. All it takes is looking at the literature and going, wow, I know nothing about that. And so it's not necessarily that I want a high schooler to be able to, parrot back to me the implications of quantum cryptography in the upcoming digital age. Although if that's something they're interested in, they're absolutely capable of doing that. But rather to use quantum as a way of teaching people to think critically and to think scientifically. Because regardless of whether or not you ever study science at the post-secondary level, there is something to be said for thinking scientifically. And so you can use quantum mechanics in the context of sort of model building. Because we have the classical world that we know. I can drop something on my desk and it will fall, right? But in the quantum case, things look very, very different. And so you can present this body of evidence to students, and you can have them start to really think about, put themselves in the shoes of the people in this, at the Solvay conference in the 1920s, and really push how they build models. So that's really where I think we can start. And, in terms of where we can end, and I'll be very quick because I know I've taken a lot of time. The bachelor's, the master's level, it's not just training physicists, but it's training, and even in the workforce training level, it's not just training physicists, but it's training the electrical engineers. It's training the CEOs, the upper management. It's training an artist to visualize quantum mechanics. There really is a place in quantum for everybody that is interested, even if you're not necessarily the one, wearing the funny goggles and shooting the lasers at things. Even if you're not, a mathematical wizard, although I claim you don't necessarily have to be a successful quantum physicist, there's a place for you. And so that's where I'll stop and let other people.
Thank you so much, Kerry, for this very inspiring and also thought-provoking answer. And I think we will add up to that as well. So I would like to continue with Tatiana. Tatiana, what do you think about this education and the quantum technologies?
Yes, thank you. I think Kerry touched on very important topics. But from my point of view, actually, I think it is actually worth already teaching or educating smaller kids. Maybe even start at I think is it called grammar school or so the fourth 1 to 4th grade. Not to really teach them to understand quantum mechanics, because of course that's not possible. But I think that it's nice to get a feeling for it. That, for example, something like quantum logic, that it's not necessarily 1 or 0 or so, but that there can be something in between. And I think there are ways to visualize something like a qubit. We have the Bloch sphere, and when we say, something like that we say, okay, in classical physics, we only know 1 and 0, but there is so much more I don't think that they need to understand that, but they should hear about it, and they should start to get an intuition. I mean, that's also what we would like to actually achieve with this Quanta project that we started, where we use these cubes, for example, to just visualize entanglement. I mean, of course, they are not entangled, but in real, we can actually show them over a large distance that these two cubes always have the same color, for example, and that this is what is visible when you have something entangled. So the systems are correlated in a way, and just that they know these are some strange effects, then actually there will start this interest, this spark will be so to say, set into these students, and they want to learn more. I mean, that's also what happened to me. I mean, I learned only about, science when I was a little kid, and I always wanted to know, to understand what is behind everything. So that's what me got motivated to actually study physics in the first place. But I also agree with Carrie that there should be multiple entry points. I mean, even if the spark is not set in this very early age, we have to actually have lanes for people joining the quantum, so to say, later and at later stages. So, for example, also for engineers to join the quantum workforce, for example, not only for physicists. I mean, that's what we also try with this master, which is multidisciplinary, which includes actually also students coming from engineering and other disciplines. And we also are now starting in Munich an initiative to actually make a retraining for the workforce. So actually, we are now trying to get in touch with companies and to actually build some training sessions for their engineers or for their staff to actually teach them quantum science. So on the level they need it. I mean, for example, people who will develop quantum algorithms, they don't need to know how a superconducting qubit works. They don't need to know solve Hamiltonians or so. They just need some quantum logic, and we will try to prepare courses that actually fit their needs. So I think that's also something very important to actually say, okay, we cannot teach everybody everything, but we actually need to teach certain people certain basics in quantum science.
Thank you very much, Tatiana. This was a wonderful insight from your part. Next up is Maria Luisa.
Yeah, so I already said a few things about education, as also Elif was remarking. But I think it's useful to add a couple of issues. So first of all is that, I mean, okay, of course, I entirely agree with what Carrie said and also Tatiana. And I agree so much that, in fact, I think that this kind of work, of educational work, I'm also imagining Carrie with all the kids coming to her lab, and I mean that she has to be very careful that the laser doesn't go in the wrong direction, right? So I really think that this is something that can be done with very small and young kids. And by the way, one of the things that we are doing also with QPlay Learn is, I know that I'm going to be very provocative and I'm going to generate a scandal, but we are really doing some pedagogical project. We are understanding with the Reggio Children how Reggio Children is a very worldwide famous institution with the pedagogical competencies, whether and how we can bring quantum physics to small children, small, I mean, kindergarten and below. Well, I know. I mean, I know that I'm going to generate scandal, but you know, I mean, kids are really, I mean, their imagination is kind of infinite. They can teach us how to imagine words that cannot be seen and cannot be touched. And they are also very able, so much more able than us to learn by experience. In fact, we very often we prevent them to make too many experiences because we fear that they get hurt and so on and so forth. So, I mean, really, I think that this is a great opportunity. Second thing that I would like to remark is that this issue about not having something that can be directly experienced about quantum physics also urges us and forces us to find alternative manners to make persons, a generic public, but also students and teachers, to give them access and make available alternative manners to look at experiments. And by the way, I think in the third part of this tonight event, we will see some examples about it from partners of our pilot project about quantum education, quantum technology education for everyone. But we have several partners in our pilot who really do this, and I mean, tonight we will see examples from Labster, but there is Quantum Flytrap. There are so many partners that are helping us understanding how to do these things. And third and last, about educational implications. For the same reasons, I mean, considering what we said in the answering to the first question about the many applications of quantum technologies to our everyday life in very sensible contexts like medicine and so on and so forth. Then really quantum technologies urges us about another educational goal. That is something about which Aditya Anupam, who is connected right now, is from Georgia Tech, is one of our partners in the pilot project, will talk. And this is about research, responsible research and innovation. Because this is something we have to make aware the general public about the many very delicate sometimes implications of quantum technology. And this is a form of education, is a citizenship education, and I think that this is one additional very important opportunity that quantum technologies present to us about education. So then there are so many other things to say, but time is really short.
Thank you very much, Marilu, for this very interesting, but let's say not scandalous answer. That was very nice. Thank you. And I will continue with Zeki. So I already know that Zeki is already doing a lot of outreach and training activities in Turkey as well. So go ahead, please, Zeki.
Thank you. Thank you. And again, I agree with all of the things that the three panelists have said before me. And as Elif said, we are, in Keyword, we are more focused on the informal education part of quantum technologies, but mainly focused on quantum computing, but a little bit on quantum cryptography as well. And we believe that the informal education part of these technologies is also very important, because for most of the world, this is something quite new. So we know that it has been around in US, and in a shorter sense, it has been around in Europe, but For places like Turkey or places like Zimbabwe or Libya, quantum technologies is a rather new shock, let's say. And there are many people, especially undergraduate and graduate students, who are trying to get into this field or trying to learn as much as they can about this field. And in that sense, organizations like QWorld or QPlayLearn, Qubit by Qubit, Labster, these organizations allow this kind of informal education, and it is also, I think, very important to provide these informal education and training efforts or opportunities for free, or let's say accessible as we can, because I mean, quantum technology is an expensive piece of technology, let's say, especially if you are doing experimental work. But if you are trying to learn this through online efforts like IBM's programs, then it becomes more accessible in that sense. So I really think that what IBM did in 2016 was a great leap forward, and we should all congratulate them for opening this path. And we should also congratulate others for following this path, because today there are other open platforms as well. To the best of my knowledge, Quantum Inspire is from Netherlands, and it is also another open access quantum device, or let's say a primitive quantum computer, let's say. And the second thing I think we should also think about is something called like just-in-time education or just-in-time training, because right now there is this huge demand for people who know what quantum technologies is, and they have this sort of certain, let's say, capabilities, or we need people that can do at least a sort of primitive work in quantum technologies that does not require a PhD, because there's this line of requirements that you really need a PhD to do what Kerry is doing right now. So you cannot just train someone to do what she's doing like in 3 months. But if you need a quantum software developer, then you can actually get a decent software developer and train them like for 3 months, and then they can start gaining experience on the job. And for that, again, I think there are really great examples like what Kureka is doing. They are trying to, prepare these platforms that people from other industries can make an entrance to the quantum market. And by these efforts, I think in the following years, we can see a shift from, oh, we need everyone approach to the, oh, we need to develop these skills in people, and we need to develop these different priorities for firms or people who are looking for employment. But right now, education is, I think it's one of the most important aspects of quantum technologies, because this is just the beginning. I mean, we will be discussing quantum technologies in 10 to 20 years as well, and people that will be developing quantum technologies in 20 years are probably in like primary school, secondary school right now. So in that sense, I agree with the panelists that people should start early, but we need people right now as well. So we cannot train 8-year-olds to do experiments right now. So we need people right now as well.
Thank you, Zeki. This opinion piece concludes now our panel part, our panel segment.
Leona, can I say one very quick question?
Sure.
I really think that I mean, this topic is so so crucial and so important. And speaking about education, I think that the kind of effort that has been put forward by the coordinators of the whole the whole initiative, the Quantum Technology Education Initiative, has been really great. I mean, this has brought together a community of hundreds, certainly 100, maybe two. I don't know whether Jacob or Kerry, who are in the coordination team, can give a more precise number. But
not
say,
off the top of my head,
Kerry,
but you know, hundreds sounds about right.
Hundreds sounds about right, of persons, scientists, and also persons from educational system, from companies, from universities, from with very diverse experiences, everyone aiming at building up this community, irrespective of one's own experience, because every one of us has many things to say, but here we are really putting together so many efforts, and this has been an educational experience for every one of us. Also from a methodological point of view. And so I really want to provide this meta message, so to speak, that this quantum technology education initiative has really brought a new way of thinking to community building in a very complex system. And so I'm really grateful to those who are coordinating us at the European level, and among them there is Kerry and there is Jacob, and also other ones who are not here today.
Thank you for those remarks, Marilu. I would like to stress that this second part opened up an interesting Pandora's box, it seems, because out of 4 panelists, we have 4 different opinions, and sadly no time to discuss it further. We had Kerry at the beginning saying that we should start at high school. Then after that came Tatiana saying, no, we should start at the ground school. Then came Marilu and pushed it even further, saying, no, kindergarten is the way. And Zeki finished up with saying, like, yeah, whatever, start whenever you want, we need people now. So definitely it was an interesting discussion. I'm looking forward to organizing an event like this, probably on a live conference or something like this, with even more people in the audience. I would be very glad to moderate it, and even to throw my 2 bits in if I have a chance. But for now, thank you for participating in the panel.